Task 10. Chapter 8. Dialog Notation and Design. Exercise 8.1. Complete the drawing tool STN in figure 8.1 and 8.3 by writing dialog description for the text and find submenu. For the text submenu, assume there are three options: center, left, and right. Justify. The tree is entered by clicking at a location in the drawing surface and then typing. You may initially assume that typing a line of the text can be regarded as a single user action, but later try regarding each character type as an action. The pen submenu has two options: a pencil for freehand drawing and a pen pot for flowing filling. The former is performed by holding the mouse button down, whistling, moving the mouse about to draw the line. The pen pot is active by simply clicking the mouse over the area to be filled. Answer. The STNs for the main menu and the graphics subsystem are in the text. We only need to do the submenu and the pen submenu. For each, the overall structure is similar to the graphic submenu. That is, the user select an option, the STM branch, and then there is description of each option dialog. First, do the text submenu considering typing a line text a single user action. This is shown in figure 8x1 to consider individual letter being typed. We simply add a loop that terminates by user typing the enter key figure 8.x2. Finally, we do the pen submenu in figure 8.x3. Note the fundamental action for the pencil drawing are pressing and releasing the mouse button rather than clicking it. Remember the more complex behavior of the watch when we consider button press and release separately. It is worth discussing the expect behavior of the package on the other option during mouse displacement. For example, when drawing line, which position is registered? The one when the button goes down, or the one when it's released. Encourage the student to try it out on different drawing packages. There is similar issue. Start text menu. Select left justified. Highlight left justified. Left 1. Click on location. Show text cursor. Left 2. Left type line of the text. Remove text cursor. Finish. From left 1, left 2, type enter, remove the text cursor. Finish. Type character, display character. Figure chapter by character input. Start, pane, menu, select port, highlight pine port 1, click inside shape, fill shape with the color. Finish. Select pencil, highlight pencil 1, then press mouse button, change mouse cursor to pencil 2, move mouse color pixel, release mouse button, restore mouse cursor. Finish. Pen submenu. With menu selection and screen button, the scenario described in section 9.4.5 is an example where an important location is where the mouse button is released. Again, get the student to look at different GUI and their detailed interaction properties. You may be surprised at the difference. Exercise 8.2. Repeat the above exercise using different notation, grammar, products, rule, GSD or GSP. You will need to specify the whole system from the main menu to the individual submenu selection, such as cycling drawing. Note the problem you have with each notation. Answer. Below are partial description in BNF and production rules. As a class exercise, you could allocate different notation to different group of students and then compare the answer in different notation. BNF description. The BNF description is quite straightforward, if a little tedious. We give the description for a main menu, part of the graphic submenu, and the text submenu. The line drawing is already described in section 6.4.1, as is the definition of position mouse. Drawing to main menu plus drawing to main menu, graphic submenu, text submenu, pen submenu, graphic submenu, drawing cycle, drawing line, drawing cycle, select cycle plus choose and center, choose plus choose edge, select cycle, position mouse plus click mouse, choose center, position mouse plus click mouse, choose edge, position mouse plus click mouse. Text submenu, select left plus choose location plus type text, select center plus choose location plus type text, select right plus choose location plus type text, select left, position mouse plus click mouse, select center, position mouse plus click mouse, select right, position mouse plus click mouse, choose location, position mouse plus click mouse, type text, enter key, printable chart plus type text. Notice the different style possible. In the graphic submenu, the option selection and the action selection are each packaged up into a name sub-dialog, draw line, and the draw cycle. However, in the text submenu, the top-level description of each option is included within the definition of the text submenu, emphasizing to the student that with a notation there is wide degree of stylistic choice. Suitable name sub-dialog can make the entire dialog far easier to read, but on the other hand, too many levels of abstraction can be confusing. Also notice that the BNF description does not distinguish between selecting a menu option or choosing a point on the drawing surface, but are described a position mouse followed by click mouse. At the level of user movement and keystroke, this is perfectly accurate, but lose the clearly perceived difference. This might be good time to introduce your students to the UIN notation Hudson et al. 1990. Production rules. As the drawing tool is largely sequential, we will expect to find the production rule description rather cumbersome. The main problem is keeping track of how deep you are in the stack of menu, submenu, and option. Watch out for solutions where the higher level option and still active, when the lower level dialog are operation. For example, the top level description might read cell graphic pop-up graphic menu, cell text pop-up text menu, cell pen pop-up pen menu. This could exhibiting strange behavior. Imagine that the user is in the middle of drawing a line using the first description in section 8.4.2. Then after selecting the first point, at which point the system even rest line is active, the user goes back to the top level menu and select text. At this point, the text pop-up menu appear, and the user is able to start putting the text annotation on the drawing area. Cell left just, left start, C point left start, left style, left typing cursor on, type line, left type, put text, left justified, typing cursor off. The user select left justified and goes and goes to the drawing surface and click at the point. However, at this point there are two rules which can fire. See point left star from the text rules above, setting the location for typing. See point rest line from the drawing rules in section 8.4.2, putting another point on the line. Where is certainly the first is that the user expects the second possible because the rest line event is still active. Also, looking back at the definition in section 8.4.2, we see that rubber banding will still be on during the entire text menu selection process. There are various fixes for this that you can discuss with your student. One way to use cleanup rules as used in CCT in section 6.3.2. For example, we would modify the top level description so that it is not always active. Cell graphic main active, graphic active, pop-up graphic menu, cell text main active, text active, pop-up text menu, cell pane main active, pane active, pop-up pane menu. The sub-menu options are then altered to update the activity event. The semantic actions have been omitted for clarity. Cell line graphic active, start line, C point start line, rest line, C point rest line, D point rest line, main active. This now ensures that the user finishes low-level dialog before selecting new option at the top level. Exercise 8.3. Develop GST diagram in figure 8.12, expanding the various nodes until you get the basic operation such as prompt, login, or the user type in the password. Expand the delete employee node using the dialog style as described in figure 8.5 and use your imagination for the rest. Answer. This is a very simple exercise and some of nodes are explained here. In figure 8.x4, the login sub-dialog is expanded, but it assumes that the user typed the correct password during the login process. To change it to accommodate incorrect password will be inordinately complex for the two reasons. First, the GST diagram does not distinguish between user choice whether to add or delete a record and the system choice. This evidence in both the delete and change sub-dialog figure 8.x6 and 8.x5. In each of these, the actual updating of the file. Login. On the left side, get a username. On the right side, get a password. On the left side, get a username. From login, read username. Into the right side, from password, read password no echo, verified password. Is put in optional box as the user may have been answered and or no when asked to confirm the update. Secondly, making the dialog dependent on the password will mean that the rest of dialog will sit under an option box with another box to abort. This was acceptable in the delete and change sub-dialog, but if this were applied to the login sequence, the resulting dialog will become degenerate and hide the normal hierarchical structure. This problem of the whether or not to include exceptional case and error behavior is extremely complex. In early stage of design, it is the normal case which one want to consider. Later on, one may refine the dialog description or alternatively annotate the normal description. Exercise 8.4. Using GSP constructor dialog for one user with an application in one Windows or multi-Windows system. Using this First, general GSP description. Provide a GSP description for multi-windows instruction using a parallel operator. How does this approach handle interface and information sharing between windows? Check employee record. Get employee number. Read and display record. View edit record. Set field and edit field content. Configure change update record in file. Delete employee record. Get employee number. Read and display record. Configure delete. From delete E or N. Incorrect password. User answer E or N. Incorrect password. User does not answer E or N. Error menu get. Delete record from file. Answer. The intention of the exercise is not much to provide clean description, but to show how complex the business of talking about multi-Windows application is. Most interface designer and programmer don't have to worry about designing the windowing system itself. However, it does help students appreciate where area like a cut pass buffer can behave oddly. The application can be anything. In fact, you may like to give the student some simple application, example the one below, and then set the exercise when the emphasis is on modification required to get the multi-Windows case working. First of all, we will give two simple applications, a calculator and a database, then we will look at putting them together. Calculator. In effect, calculator is a bit pretentious. This is really an order. The user type in either quite, which exits the application 0, which resets the adder to 0, or a number which is added to the running total. Adder from quite skip 0, so sum adder number, so sum adder. The semantic description is given is even ESL. Even at from true out next number. Even quite use input when input equals quite. Even 0 equals uses input when input equals 0. Set sum equals 0, out reset. Even number equals use input or sum when is number input. Set sum equals sum plus input. Even so minus sum equals uses sum out sum. Database. Another simple application could be a database where the use action we either quite set the key value or find key. Database db from quite skip set get key get file get key print file get key set key from get key get false set file from get file. We won't bother with the semantic description of the from even or quit, which is the same as the for the adder. The description of set and get are also similar to those for quite, so are omitted. Even get key equals use input, set key equals input. Even get minus file equals uses input database key. Set database equals database.db update. The base key input. Even print file equals uses database key out db lookup database key. The functional db update and db lookup is assumed to add a new key value pair and to look up the value associated with the particular key respectively. Multiple windows. Having got these two descriptions, putting them together is quite simple. Windows system equals adder database. However, it will be considerably more complex if we want to adder. Although this sounds a bit odd, if it were to text editing windows or two spreadsheet windows, this would be quite reasonable. We may attempt to do it simple as Windows system equals either. However, this would not work as the event name and the variable in the semantic description are global. The windows would both add to the same sum and would be random as to which windows responded to particular user event. This is an example of an unintentional interface. The only way around this is completely copy the description of either with the new names for most of the event and variable. Students can also be encouraged to look for a way of addressing deliberate sharing. For example, a common cut pass buffer can be achieved using shared variable and explicit dependency between dialog can be internal event and described in the section 8.4.3. The modified dialog below has extra command copy in the database which like get except in the also put the value from the database into share buffer and the info the buffer ready. Even tell the other to add the value in the buffer into the running total. Database db prompt quit skip set get key get fol get key get print fol copy get key send fol get key set key prompt get fol set fol prompt get fol send fol set buffer ready. The even copy is again simple test set of the input and the buffer ready is described below with the modifier added. Even set buffer use database p set fol buffer db looking up dbase key out db log up db key. The other modified to respond to the event from the database window either prompt quit skip 0 so sum either number so sum either buffer ready so sum either. Even buffer ready equals sum fol buffer sum set sum equals sum plus fol buffer. While you students work on this exercise, you can also discuss issues such as how to represent to change in the key focus. This will probably require an extra keyboard modifier process. Exercise 8.5. In the example of the digital watch in section 8.3.8, what would be dangerous state? Relate the lexical issue of the button for the digital watch to these dangerous states and provide some design advice. Does your own digital watch fit this criteria? Answer. The time and alarm setting mode the dangerous state in the we do not want to accidental change either. Design advice will be put some sort and guard which make it difficult to accidental get into the time setting mode and alternatively once within the mode to make a button which affect the time difficult to press. The watch in section 8.3.8 guard the state by requiring button A to be pressed for the 2 seconds before the mode change. It might be easy to press a watch button accidentally, but quite hard to hold it down. The solution would not of course work for a keyboard, where it is quite easy to hold key down accidentally or the watch guard this mode by inserting by the mode change button or button required actually change at the time. One has pressed this button with a sharp instrument such a pencil, not an easy slip to make. Some digital clock were to mode by making you hold the button down continuously while you changing the time. Guarding the mode is far preferable to guarding the change button, as the latter make it very hard to change the time when you want to do it. In fact, changing the time is often a problem for the reversibility of watch and clock dialogues. Typically, there is button to advance the time by 1 hour or 1 minute, but not want to put the time back. So if you press the minute advance button once often, you have to press it 87 more time to reverse to the mistake.